Investing in real estate within the state of Florida represents a high-stakes financial undertaking. The unique environmental realities of the Florida Peninsula mean that home buyers cannot approach property acquisition with a standard checklist. This region is defined by extreme weather patterns, tropical storm systems, subtropical moisture profiles, volatile soil conditions, and intense solar radiation. Consequently, the standard physical components of a residential dwelling face accelerated degradation and structural stress levels that are rarely encountered in more temperate geographic zones. When navigating this market, a standard aesthetic evaluation is completely inadequate. Buyers must look past fresh coats of interior paint, updated staging, and modernized surface finishes to understand the true structural integrity of the asset. The purpose of a forensic home inspection in Florida is to peel back these cosmetic layers and conduct a highly methodical, technically precise investigation into the hidden systems of the building. This process reveals hidden liabilities before they transform into catastrophic, budget-breaking expenses after closing. Every residential property functions as a complex, interconnected ecosystem where a failure in one component invariably triggers a chain reaction degradation across secondary and tertiary systems. In Florida, this interconnectedness is magnified by atmospheric moisture and thermal pressures. For example, a minor structural deflection or a microscopic breach in an exterior moisture barrier can rapidly escalate into severe toxic microbial growth or systemic subterranean wood rot. This can compromise the structural load-bearing capacity of the entire building envelope within a matter of months. Therefore, understanding the engineering principles behind home construction and knowing exactly how to identify early warning signs during a walkthrough is an indispensable skill for any serious property investor, home buyer, or real estate professional operating in the region. To properly contextualize the specific red flags that we will analyze throughout this masterclass, we must first establish a baseline understanding of how a property interacts with the unique environment of Florida. The state rests upon a massive limestone plateau, which is highly porous and subject to varying levels of water table fluctuation, chemical dissolution, and structural shifting. This geological reality means that the foundation of every Florida home is constantly engaged in a silent, slow-motion struggle against ground movement and water intrusion. Above the ground, the building envelope is subjected to relentless ultraviolet radiation, high winds, and near-constant high relative humidity. This environment creates a permanent vapor drive, forcing moisture from the hot exterior environment toward the cooled interior spaces of the home. If the house was not engineered, built, or maintained with these exact forces in mind, it is not a question of if a systemic failure will occur, but rather when. A truly forensic home inspection is a multi-hour, highly technical diagnostic procedure that utilizes specialized tools. These include thermal imaging cameras, moisture meters, hydrostatic pressure testing devices, and digital crawl space monitoring equipment. When an experienced inspector walks onto a property, they are not just looking at what is present, they are actively investigating what is missing, hidden, or improperly modified. The financial consequences of skipping this step or hiring a low-cost, non-specialized inspector can be absolute financial ruin. In the state of Florida, the costs associated with remediation, structural engineering, code compliance rectification, and emergency system replacements are among the highest in the country. This is primarily due to strict building codes, specialized labor demands, and high material standards. Furthermore, the insurance landscape in Florida has undergone a massive transformation. Properties that exhibit even minor vulnerabilities in their primary structural or mechanical systems are frequently deemed uninsurable by major carriers, or they are forced into high-premium markets that can instantly destroy the cash flow or affordability of the home. This reality makes the home inspection the single most critical gatekeeper in the entire real estate transaction process. It serves as your primary defensive shield against taking on someone else's deferred maintenance, structural negligence, or hidden construction defects. As we progress through this technical breakdown, we will systematically dissect the 10 most dangerous, costly, and legally complex red flags that can appear during a Florida home inspection. The foundation and structural framing form the literal backbone of any residential property, and in Florida, structural integrity is constantly challenged by geological and atmospheric forces. The primary structural red flag that requires immediate, highly detailed investigation is systemic foundation movement or settlement failure. Because Florida homes are predominantly built using concrete slab-on-grade construction or shallow footer crawl space systems, any variation in the load-bearing capacity of the underlying soil will manifest as structural distress throughout the entire building envelope. When evaluating a foundation, you must differentiate between minor, localized concrete shrinkage cracks, which occur naturally during the curing process of concrete, and structural settlement cracks. Structural cracking is typically characterized by distinct directional patterns, including stair-step cracking through concrete block or brick mortar joints, continuous horizontal cracking along stem walls, and vertical cracks that exceed 1/8 of an inch in width and show signs of lateral displacement. Lateral displacement occurs when one side of the crack is no longer flush with the other side, indicating that a portion of the structure is actively shearing or sinking independently of the main foundation mass. The physical mechanics behind foundation failures in this region are heavily tied to the local water table and the composition of the soil. Many areas of Florida feature expansive clay soils or loose, poorly compacted sandy soils situated above highly porous limestone. During periods of heavy tropical rainfall, these soils can become supersaturated, losing their shear strength and causing the foundation footers to sink under the weight of the structure. Conversely, during extended periods of drought, the drying out of clay soils causes them to shrink and pull away from the underside of the concrete slab, leaving unsupported voids beneath the structural floor. This cycle of expansion, contraction, and shifting places immense bending stress on the concrete slab. Since concrete possesses exceptionally high compressive strength but relatively low tensile strength, it will inevitably crack and fail if it lacks adequate steel rebar reinforcement or if the soil support system collapses. Another highly destructive structural red flag that is unique to coastal or high moisture environments is concrete spalling, often referred to in the engineering community as concrete cancer. This phenomenon occurs when moisture penetrates the porous exterior concrete matrix and reaches the embedded structural steel rebar. When steel corrodes due to exposure to water and oxygen, it undergoes an oxidation process that causes the metal to expand up to 6 times its original volume. This internal expansion generates immense outward pressure within the concrete block or poured structure, exceeding the tensile limits of the concrete and causing it to fracture, break apart, and delaminate from the reinforcing steel. Spalling is commonly observed in coastal properties, elevated concrete balconies, structural tie beams, and concrete stem walls. If left unaddressed, concrete spalling completely destroys the load-bearing capacity of the structural element, leading to localized or systemic structural collapse. Beyond the concrete components, the building envelope's wood framing and exterior cladding systems face severe structural risks from wind load deficiencies and moisture intrusion. Florida's building codes are among the strictest in the world regarding wind mitigation and structural tie-downs. Homes built prior to the implementation of the modern Florida Building Code often lack a continuous load path. A continuous load path is an unbroken chain of structural metal connectors, straps, anchors, and fasteners that links the roof rafters down to the wall framing and then ties those walls securely to the concrete foundation. Without this engineered continuous load path, a home is highly vulnerable to catastrophic failure during high wind events, where uplift forces can literally lift the entire roof structure off the walls of the house. Exterior cladding failures, particularly concerning modern stucco applications over frame or concrete block walls, represent another massive financial liability. Stucco is a highly rigid, cementitious material that requires precise installation techniques, including the correct placement of control joints, weep screeds, and lath systems. When stucco is applied incorrectly without proper flashing or a functional water-resistive barrier, water becomes trapped behind the hard exterior shell. Because Florida experiences intense solar heating, this trapped moisture is subjected to solar vapor drive, which forces the water inward through the wood sheathing or concrete block. The internal and underground plumbing infrastructure of a Florida home represents one of the most significant hidden expenses a buyer can encounter. The single most critical plumbing red flag in properties constructed prior to 1975 is the presence of subslab or underground cast iron waste lines. Cast iron was the industry standard for drain, waste, and vent systems during the mid-20th century. However, these pipes have a finite operational lifespan that is severely shortened by the unique soil chemistry, high humidity, and high water tables found throughout Florida. Cast iron pipes degrade through 2 simultaneous chemical processes: internal tuberculation, and external sewer gas corrosion. Internal tuberculation occurs when the iron is exposed to water and waste stream oxygen, creating an uneven buildup of iron oxide scale along the inside walls of the pipe. This scale reduces the interior diameter of the line, snags solid waste, and causes frequent systemic blockages. Simultaneously, hydrogen sulfide gas produced by decomposing organic matter inside the sewer line combines with atmospheric moisture to form sulfuric acid. This highly corrosive acid attacks the upper inside arc of the pipe, eating through the metal until the top of the pipe completely collapses. On the outside of the pipe, acidic and highly conductive sandy soils cause galvanic corrosion, which thins the pipe walls until long horizontal cracks form along the bottom of the line. When a cast iron pipe cracks or loses its bottom profile beneath a concrete slab foundation, wastewater is discharged directly into the subslab soil every time a toilet is flushed or a drain is used. This constant washing away of subslab soil creates substantial subterranean voids beneath the foundation, which leads to localized foundation settlement, cracked floor tiles, and mysterious structural slab drops. Furthermore, the saturated soil beneath the home becomes a major source of foul odors and draws pests like subterranean termites and roaches directly under the living space. To diagnose these hidden issues, home inspectors must perform a high-definition sewer camera scope inspection, running a fiber optic camera through the main cleanout or roof vents to visually map the entire length of the underground waste system. If the camera reveals channeling, structural scaling, cracking, or complete bottom washouts, the entire cast iron infrastructure must be deemed a total failure. Another major plumbing liability is polybutylene supply piping, which was widely installed in homes constructed between the late 1970s and the mid-1990s. Polybutylene is a flexible, gray plastic resin pipe that was marketed as a cheaper, easier to install alternative to traditional copper lines. The catastrophic failure mechanic of polybutylene is driven by its reaction to common municipal water treatment chemicals, specifically chlorine. When chlorinated water flows through polybutylene lines, the chemical bonds within the plastic material break down, causing the inside of the pipe to become brittle, flake, and develop microfractures. The plastic or acetal fittings used to connect the pipes are also highly vulnerable to mechanical stress and chemical degradation. Because this deterioration happens from the inside out, a polybutylene pipe can look completely pristine on the outside, while its internal molecular structure is fully compromised. Eventually, the pipe can burst without warning under normal municipal water pressures, causing sudden and catastrophic flooding that can destroy drywall, flooring, and personal property within minutes. Due to this high failure rate, properties containing polybutylene are almost entirely uninsurable in the modern Florida insurance market. Galvanized steel water supply lines, frequently found in homes built before 1970, represent a similar structural failure risk. Galvanized pipes are iron lines coated with a protective layer of zinc. Over decades of constant exposure to flowing water, this zinc layer dissolves, exposing the raw iron underneath to immediate oxidation. As rust forms inside the supply line, it expands significantly, restricting water pressure to a fraction of its original flow rate and turning the water a distinct brown or yellow color. Eventually, the rust eats completely through the pipe threads, creating hidden pinhole leaks inside wall cavities that promote wood rot and toxic mold colonization. The electrical system of a Florida residence must be engineered to handle high cooling loads while maintaining absolute safety under prolonged operational stress. A primary electrical red flag that home inspectors look for is the presence of outdated, hazardous electrical panels, specifically those manufactured by Federal Pacific Electric, FPE, and Zinsco. The Federal Pacific stab lock panel is highly dangerous due to a structural defect in its breaker design. The breakers in an FPE panel frequently fail to trip when they experience an electrical overload or a short circuit. In a standard electrical panel, when current exceeds the safe ampacity rating of the wire, a bimetallic strip inside the breaker heats up and bends, mechanically tripping the breaker and interrupting the electrical current to prevent a fire. In an FPE stab lock panel, the breakers can jam, locking the contacts together and forcing dangerous amounts of current through the household wiring. This causes the wires to overheat, melt their insulation, and ignite surrounding structural framing. Zinsco panels feature an equally dangerous failure mechanism. The bus bars inside a Zinsco panel were manufactured using an aluminum alloy that is highly susceptible to oxidation and mechanical deformation. Over time, the connection between the breaker clip and the aluminum bus bar degrades, creating high electrical resistance. When electricity flows across a point of high resistance, it generates intense localized heat. This heat causes the plastic casing of the breaker to melt, welding the breaker directly to the bus bar. Once this occurs, the breaker can no longer trip, creating a permanent fire hazard and preventing homeowners from manually shutting off power to that specific circuit in an emergency. Properties with FPE or Zinsco panels are flagged by insurance companies as high risk, and carriers will almost universally require their complete replacement before issuing a standard homeowner's insurance policy. Beyond defective panels, the presence of single-strand aluminum branch circuit wiring, commonly installed in homes built between 1965 and 1973 due to spiking copper prices, represents a major electrical infrastructure hazard. It is vital to note that multi-strand aluminum wiring is still safely used today for main service feeder lines. However, single-strand aluminum used for standard 15 and 20 amp wall outlets and light switches is highly unstable due to its physical properties: thermal expansion, galvanic corrosion, and mechanical creep. Aluminum expands and contracts at a much higher rate than copper when subjected to electrical currents. Every time an appliance is turned on, the aluminum wire heats up and expands. When the appliance is turned off, the wire cools and contracts. This continuous cycle, known as thermal cycling or creep, causes the wire to slowly back out from under the terminal screws of standard outlets and switches. This creates loose connections and narrow air gaps. Furthermore, aluminum oxidizes rapidly when exposed to atmospheric oxygen, forming a layer of aluminum oxide. Unlike copper oxide, which is highly conductive, aluminum oxide acts as an electrical insulator. This insulation creates immense resistance at the connection point, generating temperatures high enough to ignite the plastic outlet box and surrounding drywall without ever drawing enough current to trip the breaker. To safely remediate single-strand aluminum wiring, homeowners must use specialized, code-approved mitigation techniques. The most comprehensive method is a complete rewiring of the home, pulling out all aluminum lines and replacing them with modern copper conductors. However, because this is incredibly invasive and costly, alternative engineering solutions like Alumicon connectors or copolymer crimping are often utilized. These methods involve splicing a short piece of copper wire, a pigtail, to the end of the aluminum wire using specialized connectors filled with antioxidant paste and compressed with high-pressure hydraulic tools. This ensures a stable, airtight connection before attaching the wire to the terminal screws of an outlet. Standard twist-on wire nuts or regular outlets are strictly prohibited on aluminum wiring as they accelerate the failure mechanism. Additional electrical red flags include ungrounded knob and tube or early cloth-insulated wiring, overfused circuits, where a 20 amp breaker is incorrectly installed on a thin 14-gauge wire rated only for 15 amps, and a lack of ground fault circuit interrupter, GFCI, protection in wet areas. GFCI protection is required by modern electrical codes in kitchens, bathrooms, garages, exteriors, and laundry areas. A GFCI breaker or outlet constantly monitors the balance of current between the hot and neutral wires. The roof structure of a Florida home is its primary line of defense against extreme weather conditions. Roof inspections in Florida are highly technical and directly dictate whether a property can secure insurance coverage through a standard 4-point inspection and wind mitigation verification form. The first critical roofing red flag is structural deck degradation, which manifests as plywood delamination, sagging roof lines, or soft spots in the roof sheathing. The mechanical heating, ventilation, and air conditioning (HVAC) system of a Florida property is not a luxury comfort feature. It is an essential piece of environmental control infrastructure. The primary job of an HVAC system in a subtropical climate is dehumidification, and failures in this system introduce major mechanical and environmental red flags. The most critical mechanical red flag is an incorrectly sized HVAC system, particularly an oversized unit. Many unlicensed contractors or uneducated homeowners mistakenly believe that a larger tonnage AC system is superior because it cools the home down rapidly. However, the exact opposite is true. The physical destruction caused by wood-destroying organisms, WDO, in Florida can easily rival the damage inflicted by major storm events. WDO infestations represent a premier structural red flag that requires a specialized, highly detailed regulatory inspection separate from the standard home inspection. The primary pest threats to residential structures are subterranean termites, including the highly destructive Formosan variant, and drywood termites. Each group features distinct biological mechanisms that require completely different diagnostic and remediation strategies. When a home inspection reveals one or more of these 10 major red flags, the entire financial structure of the real estate transaction must be reevaluated. Buyers should transition from an emotional evaluation of the property to a highly rigorous mathematical analysis. The discovery of a major system deficiency does not automatically mean the deal should be abandoned. Rather, it requires the introduction of structural price adjustments, seller credits, or repair contingencies to protect your investment capital. To effectively navigate these situations, buyers must understand how these physical defects impact the long-term capital expenditure, CapEx modeling of the property. Ultimately, navigating these home inspection red flags transforms the real estate purchasing process from a game of chance into a disciplined risk management exercise. By understanding the engineering principles of how these systems function and fail, recognizing the physical signs of degradation, and modeling the exact financial costs of remediation, you protect your investment capital. This process ensures that the property you acquire functions as a genuine wealth-building asset, rather than an unpredictable, catastrophic financial liability. And with that, engineers, appraisers, and real estate professionals, we wrap up this Florida Forensic Inspection Masterclass. As we have seen throughout this deep dive, from the metallurgical degradation inside legacy electrical panels to the micro movements of karst soils beneath the footings, the structural anatomy of a property in this state is strictly governed by physics, thermodynamics, and some of the most demanding climate conditions in the country. When you are evaluating a property in the Florida market, remember that cosmetic finishes are just the surface. The true value and security of an investment are protected by analyzing the hidden infrastructure and anticipating failure vectors long before they turn into structural or financial disasters. If this technical breakdown brought value to your professional toolkit and you want to keep mastering forensic engineering and high-impact real estate analysis, make sure to hit the like button to support in-depth technical educational content. Subscribe to the channel and turn on the notification bell so you never miss our upcoming deep dives into infrastructure and building pathologies. Leave a comment down below. Which of these pathologies have you run into most frequently during your inspections or projects? Let's get the conversation started. Thank you for your time and for joining me in this advanced session. I will see you in the next video. Until next time.